Okay, I'm back again. I realized that last time around I forgot to turn this outer part down. So it's it needs to be a 1.675. That's my best guess. .675. It's 1.960 now. Let me get the calculator to see how much we got to take off here. So we got 1.960 minus 1.675 equals divided by 2. So we need to take off quite a bit, about 740 thousandths. Wow. I don't know, that doesn't seem right, but maybe it is. Anyway, we got a ways to go, so we're gonna start taking this down and till we get there. Nothing fancy going on here. I don't think we need any oil on this. Out of my way. We're just going to keep going here until we get down to where we need to be. We got a chamfered edge right here, so I'm going to try to determine the distance across here at the inside of the chamfer, and it doesn't have to be exactly, but we got to be close. Well, we want to leave as much meat here as possible so we can get screws in here. I have some number 10 flatheads that I think would probably work nicely. If not, if the head is too large, then we'll have to go with something else. But that's what I have now. So that would be, and that large a screw, probably 4 of them would be sufficient. That should do it. Anyway, so we're gonna shut the camera off now, and I'm gonna continue to whittle this down. Probably take me 5 or 10 minutes, and we'll be back. All right, it's been about 5 minutes, maybe five to 10 minutes or something. So anyway, I went ahead and cut this down, and it looks like possibly it's just a little bit heavy still, but we can always trim it down a little bit later, you know. So it's good enough now, and we want to leave as much meat here as possible to put our screws in. So we're gonna call that quits for right now, and we'll work on it some more later if need be. We probably need to take another little bit off, few thousandths of an inch off. So now I got to dismantle this chuck, I think. I think I'm going to at least I'm going to at least need to take the jaws out of it. So I'm going to go off camera and do that, and we're going to get it chucked up into the forejaw if we can, and we'll proceed to check these other surfaces to see how true they are. Maybe what I'll do is I'll dial in this register here and go from there. Okay, we got the chuck body chucked up in the forejaw. I put a dial indicator on this register here, and we're within a half to a quarter of a thousandth run out, so we're pretty good. Actually, this register and also the outer body of the chuck and also this, they seem to be coinciding with each other, so we should be good. I think we can bore right straight on through right now, at least to take off the top part of the thread. Nothing much is going to be in the way. Eventually I think we're going to have to control our depth though. So this part here roughly is so if we just check it with this, we're roughly 580, so 600 thousandths is all we really need to go in here. So in reality, I don't know if we'll be able to take out the threads without hitting the body of the chuck or not, but 600 thousandths is not very far in. So let's just start, get something checked up here, and let's see, what did I do with my little boring bar here? There it is. Maybe that's all we need to go with 600 thousandths. Let's see, this thing right now is we got more than we need right there. Maybe we'll just use that. And the thread there. We don't want that sticking out any further than we need to be out, because well, maybe I don't know what I did with my brush again. Let's see. Let's run this down. This is my stop here. That's what just a micrometer, and that's it. Simple. I'm gonna get that. See if I can get that put back in place here. Maybe or maybe not. get old and half blind, it's not good. Okay, we're in the slot. Let's just flush this up for the heck of it. Let's dial this back to 0. It's a 1-inch micrometer. Actually, probably a 1/2-inch micrometer would work better in here, but sometimes a 1-inch is handy. Okay, there's 0. And we're touching there. We're touching there. Let's wind this thing out 600 thousandths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. One more. There's 600 thousandths right there. That's good. We're still clear 1/8 of an inch, so we're good to go. Let's see where we're at here. Okay, we're not going to run this very fast because we don't have a hell of a big bite on that. Whoop, not good. There we go. We're making progress. It's going to take a while, so I'm going to shut the camera off. I'm guessing it'll be about 15 minutes, so I'm going to shut the camera off for... Okay, it's been 5 minutes, so we've got rid of the threads, and we're cutting into the register. So I'm going to have to dig out my 2-inch micrometer and see where we're at here. Don't want to go too deep. What I did with my brush, I found it once and now I've lost it again. Oh, here it is. So there we go. I don't think we've got any air in this. Here, turn on the... No air. I'm going to have to fire up the compressor here. Okay. We're not there yet. We got a ways to go, so we need to figure out what that might be. So we might double check the depth of that, see where that's at too. Okay. Alright. So 25, 35, I guess. Let's see what this tells us. So we need about 40 thousandths over an inch. Where were we? $37. 37 thousandths over an inch. I'm just checking with a 2-inch micrometer. I guess I need to zoom this thing out a little bit. Okay. So that's where we need to be. 137. Have to figure out what that might be. So let's see here. Looks like maybe this might be what we need. We need to take off about 30 thousandths. Alright, let's shut this camera off and let me take that. Okay, we got a good fit in there. Not as tight as I'd like it. But that said, it's adequate. So next step will be to, I think, the next step will be to maybe what I'll do is I'll take the chuck off the spindle, leave it chucked up, and thread the chuck onto the center of the rotary table to drill these holes for the screws. So I think that's going to be the next step here. I'm going to call off now and we'll go ahead and get the rotary table set up. I can do that on the Taig mill, or I can do that on the other mill. I'll just figure out which one. It's just a matter of drilling 4 holes, so we'll see how that works out. I'll dig the screws out and see if the screw heads will fit in there, but I think they may just make it. If not, I'll have to look for some number 8 screws or something. The number 10 flathead screws, the head may be too big, so we'll see. Anyway, I'll call off now for a minute. Okay, we're trying to get this thing set up on the Taig mill. So we just got a male mounted to the table. We've got the 4-jaw screwed into that, and we've got the dial indicator indicating that we're on 0. So that's it. I've done some calculations to figure out how far we got to go in each direction from 0, and so we're gonna set up the we're gonna set the computer up here quickly so we can measure the distances without using the dials and drill the 4 holes. So that's where we're headed. Okay, I got all set up. Just a quick look at the setup, and I got to find me an Allen wrench here. What I did was I'm going to drill 1 hole, and I'm going to place the screw. Okay, so you know, here's the screw, just a flathead screw with an Allen in it. And so what I did was I drilled with a tap drill first, is what I did. I clamped it with a strap clamp just to make sure that it doesn't move. Once I get the first screw in, then I'm good to go. And so that said, I'm going to place the screw. I drilled the tap drill first, and then I used a close fit clearance drill for the distance of this flange here, and then I went with a countersink. And now I'm going to put the screw in. I tapped it to the right depth. I used a bottom tap. So I'm going to place the screw. Hopefully we're going to be good to go. I'm going to see if I can get this out of my way a little bit. Well, drop the Allen wrench. I tried to blow out the hole. Hopefully, I'm not sure I got the clearance hole deep enough. Maybe I didn't. I feel like a little bit of binding in there. I think maybe what I'll do, just to make sure, is I'll run the tap in there again. Well, I can't get it in there right now. Well, okay, I got to take this out of here anyway. Take this out of here. Not sure I got the clearance hole down in there far enough. Well, that won't happen again. And I was able to use the tap just self-aligned into the close fit clearance hole, so no problem there. So the tap, there's no reason that shouldn't go in there. It's nice, and I'll make sure next time I get the clearance hole drilled deep enough. I may not have done that. Got a little air in there. I'm just going to do this on one hole so you can see what's going on, and then we'll I don't know why that screw's fitting so tight. Oh, I know what the problem is. Oh, shoot. That ain't gonna work. I screwed up. Well, now I just realized it's the wrong screw. I guess I bought 1024s and not 1032s. So now what I gotta do, I guess, gotta do something about that, I guess. Well, that's the problem. I'll have to buy some 1032 screws. I can use 1024s. Let's see if I can find an Allen for that. Yeah, that's the problem. That's why I couldn't get the screw in. Well, that's alright. This will hold it temporarily. I can't fix it. Well, that's in there and that works. So all I need is a 1032 screw. I like these screws. I may have some 1032 flatheads with just a Phillips on them. We'll see. Anyway, okay, so that I'm going to take the strap clamp off now and come over to the other side, the same distance from zero, and do this side. And in the meantime, I'm going to dig around and see if I don't have some 1032 flatheads with a Phillips in them. So I'm going to shut the camera off now. Okay, I'm placing the second screw. I'm going to have to get this out of here though, I guess. Got to take it out anyway. Okay. I turned out I had a whole bag of Phillips heads. Not my desired choice, but they're okay. They'll be fine. Just need to worry about the shear, that's all. Okay. Need a rag here to wipe my fingers. Okay. We need to go back to zero. The x-axis here. Okay, there's zero. We need to go the y-axis. We got to go 606. We'll drill the back hole first, I guess. There we go. So there we go. 606. Okay. Well, shut the camera off here for a second. Okay. As you can see, I just placed my last screw. So I guess I'm sort of done. Actually, this didn't take very long. I don't know. But it has been a 5 or 6 hour day, I think. Or at least, no, actually 1 o'clock, 3. So about 4 hours today I've spent on this to complete this little task. So the proof will be in the pudding, I guess. I guess at this point we'll take the 4-jaw off the table and see what we can knock it loose. I gotta take it over there and loosen the jaws, take this chuck body out of here, and so you get the picture anyway. Hopefully it's been some help. Hopefully somebody out there will give Taig some business and spend $20 and buy one of these 4-jaw chucks. My thinking is it's going to have, definitely he's got to have more holding power than the 3-jaw chuck. So, and if this thing, if I got any run out in the piece I chuck up, then we can tickle the jaws a little bit and get it to run true. But hopefully we'll be pretty good, as good as these things can get, I suppose. Anyway, I'll call off for now, and maybe give you an update later on. Another thing I might mention: the chuck body, or the chuck, is $20. Also this little face plate, or whatever you want to call it, that I use for an adapter, that was $9.15. I forgot to mention that. So anyway, that's it. I'll call off now. Thanks for watching. Bye.